Hey, Mark, I'm going to go ahead and go over the answers that were marked incorrectly. Starting with number 4, what is a type 3 error? There is no such thing as a type 3 error per se. In all the dozens of books I've ever read, there is no ever mention of type 3 error, but there is kind of like a running joke between statisticians. A type 3 error is when you get the right answer to the wrong question, or vice versa. You get the wrong answer to the right question, or something like that. But there is no such thing as type 3 error in the world of statistics as we know it, and that this was not an important question. All right, question 8. I made a boo boo. I didn't have Manova in there, so it just originally stated the dependent variable should be blah, blah, blah. But I screwed up. It should be in a Manova. The dependent variable should be related between zero point 0.3 and zero point 0.8, somewhere in there. So that's not a very biggie. Going down. Next. All right, which of the following is a good explanation of effect size? So effect size is the percent of the variance in the DV that can be explained. So here it is right there. The correct answer is this one. Okay, effect size is the percent of the variance of the DV that can be explained by the statistical model, either by the grouping of the ANOVA, right? The partitioning of the groups in an ANOVA can explain the variance, or starting next semester, the relationship between two variables can explain the variance. So with the IV, the independent variable, the only variance we're interested in to make sure that the variance of one level of the IV is the same as the other levels of the IV, right? That's the homogeneity of variance rule. But again, with the IVs, we don't really give a rat's patootie. They don't have to be normal. They don't have to be anything, okay? Okay, this one. So you have a 4 by 5 by 3. So that means you have one IV with 4 levels, one IV with 5 levels, one IV with 3 levels, and sex could be one of these. So, like an idiot, I was assuming there's only 2 sexes, male and female. But you're right, there could be other sexes, I guess. But one of these should have been a 2, right? That would have represented both male and female gender. So this would have been false, unless, of course, you want to apply one of those other strange sexes. All right. Let's say you had a 95% confidence interval for the difference between two group means. That's the important part. The difference of the means, if you look at that confidence interval, -1 out to +2, so look at the number line between -1 and 2, 0 is right in that confidence interval. And that's what the null is stating. The null states that if you take one mean and you subtract the other mean, the difference between them will be 0. So the rule of thumb is if your confidence interval for the difference between two group means contains a 0, you cannot reject the null. I'll say that again. If you have a 0 in your confidence interval for the difference between two group means, you cannot reject the null. Question 21. So this is a plan comparison question. So you got different plan comparisons, 1, 2, and 3. So comparison 2 has too many groups versus too few groups. That is never an issue. You can have 1 against 10 if you want. Okay, so it doesn't matter how many groups you're comparing to each other. Okay, number 2, comparison 3 would not be orthogonal. So orthogonal means that the comparisons are independent and non-overlapping. So that means if you had one group in both of the sides that you're comparing, that means you're violating the orthogonality, and I think that's the correct answer. Let's look at this. Comparison 3, we have sales in the first group, and we have sales in the second group. So that means that this comparison 3 would not be an orthogonal comparison. So you answered comparison 1 would not have independence of observation. That's wrong. Okay, independence of observation is when somebody in one group or one level is interfering with somebody in another level. That's not what's going on here. So again, comparison 3 is not orthogonal because it has like the sales department in one side of the comparison and on the other side of the comparison. All right, what does main effect mean? Main effect means that there's a significant difference between the levels of an IV. Think of a one-way, real basic ANOVA. So like the military branch, you got your Army, your Navy, your Marines, et cetera, et cetera. The DV is the number of push-ups. And if there was a significant difference in the number of push-ups between the military branches, that would be the main effect of military. So what you did was the main effect is when the main level of one IV has the most significance on the DV. Yeah, it's poorly worded question. I apologize for that, but the right answer is when there is a. It looks like E, right? The main effect of the independent variable indicates that there's a significant difference of the dV between the levels of the particular IV. It's just a real basic, is the F significant for that IV? That's what the main effect is, okay? Okay, which of the following will not increase the power of a study? So let me show you something here. Where are you? Boom. Here is power. Here it is right here. Power is the relationship between the following: sample size times effect size, that's your numerator, divided by within group error, right? That's your error term within group variance. So let's go back to the problem. So if you increase the sample size, that would increase the power. Use standardized data only, that makes no sense. Increase the effect size, and it will increase within group variance. That's true too, but that is just a shitty question. This is a poorly worded question. I'm going to reframe that, okay? So it should have been this one. Increase the within group variance error term. Again, so if you increase the error back here, so if the denominator goes up in value, power goes down, right? They're inversely proportional, but that's a poorly worded question, and I apologize. Please don't tell anybody. All right, which of the following would use a between group ANOVA? A teacher is curious to see as to who will score higher on the SAT math section, either left-handed students or right-handed students. That's not wrong. You could do a between group ANOVA with that, but since there's only two groups, the correct answer would probably be the independent t-test. So again, you can run an ANOVA with simply two groups, but what you're really doing is the independent t-test. So that's really not the right answer, but you're not 100% wrong there. So baseball coach wants to see who can hit more curveballs. Right? Again, there's only two groups here. That would be a t-test. Teacher wants to pre-test decimals software, and then she gives a post-test. Pre and a post. That is not an ANOVA. That would be actually, and in a 6 months follow-up, that would be a repeated measures ANOVA within group ANOVA, not a between group. Consultant wants to see a job difference satisfaction scores. That's your DV between 8 different departments at a large company. That is your answer, D, right? Because there's one IV, we can call it department with 8 levels, and the DV is job satisfaction, so it's D. So let me check E. The manager wants to see if there's a difference between carpenters, plumbers, and iron workers in regards to what color truck they own. Okay, that would be a categorical versus categorical. That would be a chi-square test. But no, answer's D on that one. Last one. Which of the following is the best definition of the critical F ratio? So the word critical is critical. That's the F ratio you get out of a book. In other words, if the null were true, then you should have got the critical F ratio, that value or less than that value. Again, if the null were true, you should have gotten less than the critical F ratio. So let's see what the questions are here. If the null were true, then the calculated F should be equal to or less. That's it right there. First one is A is the right answer. And you picked if the null were true, then the critical F ratio should be less than the calculated F ratio. Other way around. Okay, so it's the other way around. If the null were true, your calculated F, the one you work so hard for, doing all those hand calculations, if the null were true, your calculated F should be less than the critical F. Okay, so that's that answer, and I think that's it for you. But you did good, man. You did really, really good. So I'm very proud of you. So don't worry about it. All right. MGZ out. Have a merry holiday, dude. See ya.